Hey, welcome back. Today we're looking at 3-10 inverses. It's going to be kind of a lot of stuff, but not too difficult stuff. The main picture here is to remember, or the main idea here, maybe you don't remember, but it's that two functions are inverses is if we compose them, we end up with x. All right, so it's a good way to find inverses. So the example is asking us, are the functions inverses? And what we're going to do is we're just going to compose them and see if they equal to x. If they equal to x, they're inverses. If they're not equal to x, then they're not inverses. All right, so it doesn't matter which we compose, which way we compose them. So if we put g into f or f into g, either way, it should come out to x. So let's see. Let's put g into f. So let's do f composed of g of x. So I'm putting this into our x here. So we have x minus 2 plus 2. All right, we substituted our x with x minus 2. All right, so x minus 2 plus 2, well, negative 2 plus 2 is 0, so this is x. So yes, they are inverses of each other. And if we did it the other way, we'd come out with the same exact answer. Now let's look at number 2. So I don't know, let's do g composed of f this time, just to show it doesn't matter. Okay, so, excuse me, we're plugging this into our x here, so we're going to have a complex fraction. 1 over 3 parentheses negative 1 over 3x. Right, so at this point, we can multiply it. Let's do this. So let's say 1 over, or we could just simplify it. Either way is fine. So 3 and the 3 cancel out, right? We could write that as 3 over 1 for those of you who like it that way. So then we have 1 over x negative. All right, so we said last class or last lesson that anytime we have a complex fraction, we're going to multiply by the reciprocal. I'm running out of room. So that this is going to be 1, right? That's our numerator. And we're going to take that division sign and change it to multiplied by the reciprocal of our fraction, which is negative x over 1. And then the 1's cancel out. And this whole thing is just going to be negative x. Okay, because we have a negative x and not just x, right? It says if it's equal to x, not if it's equal to negative x. This one is going to be no. So f and g are not not inverses in this case. It's got to be equal to x for them to be inverses. Okay, so this next example, we're looking at a set, right? We have the set of points, negative 9, 0, negative 7, 0, negative 2, negative 7, and 14, 3 for g of x. And then we have an equation, h of x is equal to 3x minus 10. So the thing to remember is that for inverses, the x and y switch. So that's a very important thing to remember for math going forward. So if we're given a set of points, right, so we're looking for the g inverse of 1. So we're looking at when y is equal to 1. Oh, we don't have a 1. Let's change that number. I don't know if they made a mistake or I made a mistake. Okay, so let's do g inverse of 3. So it's saying instead of x being 3, when y is equal to 3, what is the x? So when y is equal to 3, x is equal to 14. Okay, so h inverse of x, again, for our inverses, x and y switch. So they're not asking us for a number. They're asking us for what does this expression look like. So remember that the h of x from here. So we have h of x equals 3x minus 10. We're going to say that h of x is like y. Okay, so what we're going to do, step 1 is switch x and y. And then step 2, we're going to solve for y. Okay, so we're going to solve it. We're going to add 10. And then we're going to divide by 3. And cancel out. So y is equal to x plus 10 over 3. If Alex doesn't like that answer, we can split this up into 2 parts. You can say that y equals x divided by 3 plus 10 divided by 3. Either way it should work, but I don't know, sometimes Alex is funky like that. So again, just make sure you switch your x and y first, then you solve for your y, and that will be your answer. Okay, and then the last one, we can do the composition thing here, but the real idea here is, remember we said that anytime we compose a function and its inverse, it's equal to x. Well, this whole thing, if our x is equal to 4, this whole thing's got to be equal to 4, right? Because h and h inverse, we know they're inverses of each other already. So that thing should be equal to 4, but we can go ahead and check. You guys don't have to write this down if you don't want to. So let's say we're going to plug in h inverse into h. So this is our h of x. 3, that's the outside. And in place of x, we got to put this whole thing in here. So we're going to put x plus 10 over 3, right? And then we're minusing 10, subtracting 10. Okay, so again, what we did was we took that as our outside function. We plugged the inverse that we just found, right? H inverse of x is that thing. We plugged it in. Now look how nicely it simplifies. 3 divided by 3 is 1. There's no need for parentheses. X plus 10 minus 10 is x. And now let's plug in our 4. And that should equal 4. Right? So anytime we have an inverse and a function and its inverse composed, that's equal to x. So if we have a number here, whatever that number is should be the answer. So this is going to be equal to 4. Okay, one more time. So we're looking for g inverse of negative 4. So it's asking us what is the x if y, right? We said that we're switching the x and the y. So we're looking for when y is negative 4. Well, then our x is 9. H inverse of x. I'm going to have to algebra. So we're going to start y equals 3x plus 8, right? Because we said h of x is like y. We're going to switch our x and y. And then we're going to solve for y. So do that real quick. So y is going to be equal to x minus 8 over 3. That would be our inverse. And then the last one, again, we have h inverse and h, and we're plugging in negative 3 to that. We could do all the math on it, but because we know that h inverse and h are inverses of each other, this whole thing should just be equal to negative 3. Okay, last type of problem. So f of x is equal to square root of 2x minus 6 for on the interval from 3 to infinity. So we're going to find the inverse and state domain. So again, when we find the inverse, we're going to switch our x and y. So we're going to say y equals 2x minus 6 in the square root. We're going to switch our x and our y. And we're going to solve for x. So to undo our square root, we're going to square both sides. So x squared equals, the square and the square root are undone. I'm going to go ahead and solve this algebraically. X squared plus 6 equals 2y. And then we divide by 2. So x squared plus 6 over 2 equals y. That would be our inverse, right? So we did the first part, find f inverse. And then the domain, remember we said we switched the x and the y, so this would just be domain for this inverse function is going to be the number switched around. Making sure we keep the bracket with the 3 and the parentheses with the infinity. Okay, pretty cool. Let's do one more. This one's a little bit more complex, but not too much. So we're going to say y equals the square root of x plus 4 minus 10. Notice the minus 10's outside of the parentheses. All right, so we're going to add our 10. Oops, sorry, we didn't switch our x and our y. Okay, add 10. We're going to undo our square root by squaring it. I'm not sure if it's going to make you do the x plus 10 times itself thing, right? X plus 10. Right, and then we're going to have to multiply it out. Maybe. If not, let's keep it like this. I like it like this. Okay, and then y is equal to x plus 10 squared minus 4. Hopefully it'll take this answer. If not, you have to go ahead and do your multiplication, and then don't forget to subtract the 4 at the end. All right, and then again, the domain here, we're just switching the x and the y. So we have from infinity to negative 4. With your bracket on the negative 4. Okay. So again, hopefully it'll take that answer. If not, you're going to have to multiply that x plus 10 squared out. But hopefully it'll accept your answer as is. Okay, that's it for today. Good job. If you have any questions, please bring them in next class. We can talk about them and hopefully get your stuff cleared up. And yeah, good job.